So, hello everyone. Uh, let's wait for a few minutes to get the guest arrives, other viewers. Yep. GM, GM, GM.
Mm,
Whoa. Hello Anthony. Hi Brian.
Anthony, Brian as well.
Hi. How you guys doing? Nice. How are you doing it? GM, GM, cam.
Sweet SVG NFT goodness.
Yeah. And so Reddick, how long you have been working on the development side of NFTs and other stuff?
I've been in Web3 for over a year, something like that, year and a half maybe. About half
Nice.
a year at QuickNote, and yeah, NFTs was one of the things that got me into Web3. I started looking at it, then I got interested
Yeah.
how it works under the hood, and then started looking at the
Right.
code, and then started playing with it. Okay, what if I do this or that? What if I can try and change it? And then SVGs, which is like fully on chain, and then you can fully control that. So like step by step by step, I started at looking at it just like for the art, and then started to be interested more and more and more to a point where we are now running a workshop on it and just creating ourselves the SVG NFTs, which we can put that on blockchain live, hopefully within an hour
Right.
from now. So that's our goal.
Right. That's awesome. I've also been into the space for like 8 or 9 months almost, and like NFTs are the things which got me into it. I just saw something about the Bored Ape collection, JPG selling on millions of dollars, and then interested like my interest started. What the heck is going on in the world? Like why a JPG would be costly so much? So then I got into it, and then I started the development over there, and right now we are over here.
Awesome. Okay. Do we want to wait a couple more minutes for the rest,
Um,
or do we
I
start
think
now?
yeah, I think we should go on. So, hello everyone. My name is Yashkar. I'm from India, and we at Developer DAO are hosting these workshops weekly and trying to do it like 2 times in a week, bi-weekly. So, first these workshops were for the DAO members only, but now we are opening it for the whole crowd, whole community to spread the education about the whole Web3 thing. And today over here as a guest we have Radek. He's developer advocate at QuickNote, and he will be explaining us and like explaining us how to create and deploy 100% on-chain SVG NFT, and that too in an hour. So yeah, I think we should go on. And Radek, if you'd like to introduce yourself, that would be awesome.
Yeah, hi everybody. Good to have all of you watching live or watching later on YouTube. I'm Radek, I'm developer advocate at QuickNote, and my goal here is to take you from, I don't know what your stage is, but could be even from zero. I'll go through all the steps needed to a live NFT collection, SVG fully on chain without any third party servers in an hour. That's the goal. We'll see if we can make it. Maybe we'll go a little bit over time. Hopefully not. I'll try to explain everything as we go. But if you don't see something, or if you don't understand something right away, there's a whole repository here, which you can then clone later. After the workshop, I will also add a code, like the file with the code that we will create. So you will be able to go through that as well, because right now it's an empty repository with the smart contract file quite empty with some few scaffolding. So you will be able to go through that as well. There's a link now in the comments section where to go for the repository. So you don't need to go and create right now, but you can do it later on. You will have everything for it. You will have all the code, you will have all the instructions how to do it, what to do step by step. So don't worry if we go fast. The goal is to show what's possible. The goal is to explain the thought process, and the goal is to show how the SVGs work quickly, and then how to put the SVG code fully on chain, how to deploy it, how to see it on the blockchain, on the OpenSea, on the test network. Then you can go to the main network, put it on Ethereum or Polygon or wherever. So that's the goal of the workshop. And you will have all the tools to do it yourself later on, and also possible next steps, what you can do after you create that, how you can take next step 2, 3, and 5 to start creating more and more sophisticated NFTs. So
Nice.
having our goal here, so this is what we want to create. So the name of the NFT is Balls of Art. We're creating art here. We are creating art with balls, so that's why it's Balls of Art. And that's a sample NFT that we want to create. This will be randomized, of course, but that could be one of the outcomes of this NFT. So everything will be generated with SVG. It's not going to be a PNG file that needs to be stored on server somewhere. And there are a few goals of this. We are not just creating an NFT and SVG, but also other goals that I want to achieve. So first of all, how to structure an NFT project. So what to put where, how to deploy it, how to optimize for gas. That this is important, especially for SVG NFTs, because SVG is could be a lot of code, and all that code will need to be stored on blockchain rather than just like one link to an outside server, which is just a couple hundred bytes. We store everything on blockchain, so we need to optimize everything. We need to optimize for storage, and that's also one of the goals of this. Another is how to randomize things. For this workshop, it's pseudo random. We can go then to the next step with the truly random numbers from oracles, but not for this one. How to draw simple SVGs. If you've never done that, we'll go through this one as well. And how to start playing with SVG animation. So this eye here. So let's maybe look how it's going to look. So this.
So, Redek, just a second. Like someone has said to like increase the font size, it would be good.
Sure.
Yeah, awesome.
So no problem. And this is what we are going to create. So this is based on the code that we want to create today on the workshop. Balls of art, and these are all randomly generated NFTs. So whenever you run a function called mint the balls of art NFT or something like that, I don't remember the name, you get that. And as you can see, maybe the eyes will be blinking on the NFTs every 10 seconds, like here, which is also randomly chosen which ball will be a blinky ball. So that's what we built. And everything will be randomized. So the background color will be randomized. The size of the ball, so this is a rare one because the triple ball is the most rare one. And we have 2 triple balls in this one. So this is a rare one. This is quite common one. And as you can see, different colors, different ball sizes, different smiley ball, and different background color as well. So that's what we want to do. In an hour, we want to have this on Testnet. There are a few SVG resources if you have never done that, if you have never created SVGs. There's one quite a beginner-friendly tutorial at W3 Schools, one a little bit more sophisticated for intermediate at Mozilla Developer Network. We'll go through it quickly soon, but first let's start creating the repository cloning. So this is from the repository here, all the instructions, what to do. Step number 1 is to clone this repository. So we are cloning it, and to be able to start working, we have it. Now we go to the Balls of Art tutorial, the name of the NFT, the name of the repository, and we can start coding it. So we have it on our computer now, and we have it locally, so we can install all the dependencies with yarn. Let's install. Should take a few seconds. Good. Now we have all that we need for local development. After we are finished with local development, we will need to add a few variables in the environment file, so that then we can deploy to testnet. We will need the RPC API key for the testnet for Girly. We'll use quick note for that. We also need a private key because we need to pay ETH to be able to deploy to testnet, even if it's test ETH. We need a wallet with test ETH in it, so that we can deploy it to testnet. And we need Etherscan API key. It's not strictly necessary, but we don't have time today during the workshop to create a front end where we have a page with a minting button. So we will need to mint it on Etherscan manually, to just like go and push that NFT like mint function manually. And for that, we need to verify the smart code on Etherscan, and for that we will need the NFT. So we'll do that once we are ready to deploy. But first, we have everything, all the dependencies done. Let's see if our simple code compiles, if everything works properly. Yarn half-head compile. A few seconds, we are done. In 5 seconds, everything compiled successfully. So we now ready to start deploying, start developing. For local development, let's run a local blockchain. We have a local chain running on our machine, and let's deploy it to a local. Well, we compiled it. We're now deploying. Boom, deployed. Everything works properly, and when we check our local chain, it says contract deployment, balls of art, contract address. Everything works properly. 1 million gas used for the deployment. Everything's fine. So far, so good. So now we can start. Now we can start coding. So for that, what we need to do first. Let's go to balls of art, smart code file, smart contract file. So I have added already a few imports. We will be working with the ERC721, which is more or less a standard one for the NFTs, and which is also what we want for an SVG. Ownable and base 64. This is standard. These are standard libraries to work with NFTs. The ownable is for blocking the reentrancy. Base 64 is for converting between strings and bytecode. Console for us to just put console code when we deploy it for debugging. So first thing, I have created something like a table of contents of sorts to go and see how to think about and how to structure the NFT collection, the NFT smart contract. So this is what we want to create. We want to create this kind of NFT. So we need to something to store the instance of each ball, because we will have many balls in each NFT from 3 to 9. And so we need a structure to store the NFT. So that's going to be our first order of business, to create a structure, because without it, we will not be able to do anything. Once we have that, then we need to configure a few parameters for the collection as a whole. So first of all, how many NFTs, how many tokens do we want in our collection? Normally it's 10,000, but we want it to be exclusive, so let's go with 111. We are a really unique and exclusive collection. We'll go with a much smaller number. Total supply is, this is from ERC-71, the number of tokens already minted. So every time we mint an NFT, this will be incremented. But for now, we haven't minted any, so we are just starting with 0. And the mint price, because we are an exclusive collection, we don't want it to be free, but we also don't want to be expensive. So let's say 0.001 Ether. That is going to be our mint price. Events, this is where we put events in the smart contract. Whenever anything important happens, in our case, it would be, for example, an NFT is being minted, then we will emit event, and this is where we will put the event here. Once we have it. For now, we haven't minted anything, so we are not defining the event here at the moment. Then the constructor, which every smart contract needs. So this is going to be type ERC-721, which takes 2 parameters. First is the name of the collection, and second, the name of the token. This is not really used anywhere, so we can come up with anything we want. So balls of art, and let's call the token bar. Now, to see how to structure and think about the NFT and about this one specifically. First of all, what do we need? We need to start with the canvas. So the canvas will need a color, a random color, and that's what we will be. Maybe, I don't know if you see. So yeah, maybe like this. This is going to be background, the function that returns a random color for the background. And the second is the function that returns a random color for the ball. The reason why it's not one function like return color is that I want to have 2 different sets of colors, one set for the background and one set for the balls, so that we don't end up with an NFT where background and one or more than one of the balls are of the same color, so it just blends in. So it's going to be 2 different sets of colors, so that's why 2 different functions. Once we have the color for the background, once we have the color for the ball, then we can create a structure for that specific goal. We can create an instance of one ball where we will store all the necessary information to create the code for that ball. Also, what else needs to be done? The ball needs to have a size. It can be single ball, double ball, or a triple ball. So that's what this function will do. Draw ball size, aptly named function. It will return 1, 2, or 3, depending, randomized. Once we have the size, we have the color, we have everything, then we are ready to create an SVG code for one single ball. So we can create the ball, we can add the glow to the ball, and we are ready with one ball, which is good. Now once we have the ball, the next step is to create a line of balls. It could be a line with a single ball if it's a triple, with 2 balls or 3 balls, but yeah, we are creating the whole line. And once we have the line, then we are almost ready with everything because we can create 3 different lines. The last thing that we need to do is add the smiley eyes, which are animated, and that's what the function draw eyes will do. So now we have everything. We have all the code needed to create our single NFT. And the next function will just put all the code together, and that's generate final SVG. We run all the functions, we put all the balls into lines, we put all the lines on top of each other, we add the eyes on top of it, and we have the final SVG, which we are now ready to put into blockchain. We want to store everything on the blockchain, and that's the function that is going to do it. Token URI function is, it will have the whole SVG code in the URI of the specific token. So the token URI is stored on blockchain, and the whole code will go into that function. So we will need to modify it compared to a standard ERC70Y. Now we will override that function and put all the SVG code into that function. And once we have everything, once we are ready to put the SVG onto blockchain, the last step is to actually mint that NFT so that we can put it on OpenSea, we can sell it, we can buy it, or we can just be happy that we have it. So that's the structure of the smart code, smart contract for the NFT. Once we know what we want to do, now we are ready to start coding. So the first thing that we need to do is to create a instance of the ball, and for that, for that I have started with creating the instance in Figma. We will need that, as we will see. Yeah, I have played with different concepts, maybe trying different ball sizes, different glow or glow direction, but or even vertical or horizontal. But I ended up with this. So that's what we want to create. And for example, let's try and recreate this one. So let's see. First, the whole NFT will be 1250 wide, 1250 tall, so it's going to be a square, 1250, and the first ball is going to start at coordinates x150, y150 is going to be 950 wide and 300 tall, and the single ball is 300 by 300. So we have all the parameters for the balls. If you create it in Figma, it's much easier because you can very easily see all the parameters that you need. You don't need to visualize anything and calculate. You have everything here. So you're making your life easier by creating this. So we are creating the ball structure. And for the ball parameters, we need this. So for the ball parameter, we need the x and y. So where the ball starts. So here, so for example, this starts at x150 and y150. So that's the parameters for the ball. How wide it's going to be. For this one, it's 950. It goes across the whole line. How tall? It's 300. The string, it's what color it's going to be. It's a string representation. And random base. Random base is going to be used in many places in the smart contract. It's actually the seed that will be used to create a random number. And we need to have random seeds for each ball so that then we can come up with random colors, random sizes for each ball. Otherwise, every ball would be the same if we provide the same seed to that function. So we are ready with our ball structure. We are also ready with our NFT parameters, NFT collection parameters. Now we can start generating the function itself. So background colors. We need to provide, for the background color, it's simple. We only want to provide a random index number, and it will return, it's going to be internal pure function, which returns a single string stored in memory. A string will be the representation of the color, so we give an index and get a color back. The way it works is that inside this function, we have an array. That's why we are providing an index. The array will have 7 colors. And by providing a random index, we will get a random number from these 7. So background color is 0, will provide white, and so on. So a simple function to return the color, and let's see if everything compiles properly so that we don't have any errors. So far, so good. Everything is fine. So now we can start moving a little bit faster. So very similar function for providing the color for the ball. It again needs a unit index of the array. It's going to be pure, internal pure function, which returns string memory. And it's exactly the same as previously. It's size 33 array, background colors. And it's going to be, it's going to return a random one from 33. Now we have our background color random. We have background, the color of the ball. Next, we can create a ball structure. Maybe quickly, let's see if there are any questions in the. No, everything's fine. So now let's go with the next function. We need to create a ball structure. Ball structure created. So we create ball structure based on this. So this is exactly the parameters that we need to pass to this structure: x, y, width, height, fill, and random base.
Excuse me, Red.
Sure.
We got a question over there, and it's an interesting word. That's why I'm putting it up right now. Would you like to take it right now?
Yeah, sure. Any implementation of accessibility features on NFTs for the visually impaired? That depends on what you choose and what kind of accessibility you want. This NFT collection specifically is a play on colors. So if someone is visually impaired, then we have very limited option to play with it. We can make it black and white, but then it will be a different collection, a different concept. But that's also an option. We can play with the shapes and sizes, which then don't depend on the colors. So that very much depends on your idea of the NFT collection rather than any implementation details.
Nice.
And please ask your questions as you go. I want for everything to be clear. Not to not rush through everything, so that we have the understanding what is going on. So now we create the ball structure. What we need to do is we need to pass the x, we need to pass the I, width, height, and random base. All based on the structure that we have created here at the top. X, Y with height, fill, and random base. Okay. Good. So it's going to be also similar internal function, pure, and returns. This is the first time it's different. It doesn't return a string, but it returns an instance of a ball, which we will then be using elsewhere to create everything that we need. And it's pretty straightforward. We are returning, creating the instance of the ball with X and Y that we have provided, width and height as well. This is how we create a random color. So we have a random base, which is like a seed for the random. This is a very large number that we will generate in a different function later on. And once we pass to the modulo of 33, 33 is the size of the ball colors array, it will return a random number between 0 and 32. So then we pass that random number between 0 and 32 to ball colors function, which will return us the color from that function. That's how we create a random color for that specific ball. So now we have our ball structure, and now we are ready to use it in the functions. Once we have the structure of the ball, we need to be able to tell what's the size of the ball with drawable size. Drawable size actually has two parameters. So it depends where we call it. So for example, let's say we want the size of the ball here for the bottom left. And there are three options here. It can be a triple ball, double ball, or a single ball. And if we want the size for the ball here, it could be any of those. But if, for example, it comes up as a size 1, then we need to calculate the number for the second ball. Now we can only have either double or a single because there is not enough space for a triple. So we need a parameter to have a max size of the ball. So that's what we are going to provide to this function. So we provide uint max size, and again, as always, random base, which will be a seed to randomly generate that size number. And to make things more interesting, it will not be just like a random drawing of if it's going to be double, single, or triple. We want to assign parameters to it. We want to assign probabilities. So we want to be able to tell how likely it is to. We need to specify visibility. So it's an internal pure function which will return just uint size. It's going to return 1, 2, or 3. So in order to assign probabilities, we think in percentages. So what we need to do first, we need to generate a random number between 1 and 100, which is, again, this seed. And modulo 100 plus 1 will generate a random number between 1 and 100. And then let's set probabilities here. So let's say the triple ball is 20% likely to be drawn. Double ball, 25% likely. Everything else, it's going to be a single ball. So if the max size is 3 and the random number that we generated here is less than 20, then we return 3. It's going to be a triple ball. If the random number is 20 plus 25, so it's less or equal to 45, then we return 2 and exit the function. If it's more than 45, we return a single ball. We return 1. Else means that max size is 2. So again, we assign probabilities. Either 2 is 30%, everything else is 1%. So this is for like a second ball for us to draw. And it returns either 2 or 1 if the max size is 2. So now we are ready with a random number, which we can also tweak the probabilities of how rare we can make the triple. So here I was quite generous with the triple. I wanted to show that it's possible to have a triple. We can assign, like, for example, 1% probability, and then it will be a really rare one. We have it at 20. 20 for each row, so that it's actually even higher than 20. So now we have the ball size. What we need to do is now we are ready to create an SVG for a single ball. SVG for a single ball is we haven't yet created SVG at all, and this is what we wanted to learn. So let's go and quickly do that. If you've never created an SVG, then let me find the link. Let me find the link. If you've never created an SVG, then there's a very beginner-friendly tutorial, HTML SVG. It's very easy, like, for example, here, how you create an SVG circle. This is the code that creates it. There's a circle function. You add parameters, so where do you start, X and Y. This is the radius of the circle, and the stroke is the color of the border, and the width of the border, and the fill is yellow. Boom, you have a circle. An interesting feature here is that you can modify and run this code here. So this is what we are going to use to create our own. And I will go quickly through this. So maybe I will present the final code for the SVG so that we don't spend too much time on it. SVG. So this is the SVG code for our NFT. Like, we are trying to recreate this one, specifically this one. First manually, then we will do it in the smart contract dynamically. So manually, we want to recreate this one. So first, what we need to do, we need to create a view box. So how large the SVG is going to be. And view box is 0 and 0. This is X and Y starting point, and 1250, 1250. It creates a view box for a square 1250 by 1250. But it doesn't do anything yet. We need to add the rectangle with, this is the background. We add a rectangle with a specific color of the background, and this is going to be light blue. Then for each ball, so this is the final code, but let's try and, for example, run this one. That there's a function to create a circle, like here, like we have seen. We provide X and Y for where to begin it, and we provide the radius, and that's it. But it's easy to create a circle. It's not easy to create, and it's not even possible to create with that function a double or a triple. The way to do that is that first we create a rectangle. By creating a rectangle, here, this is the red one, we do it like the width of the double ball, and then we do a little trick that we add a radius and the border radius, and actually the border radius is half of the width of the rectangle, which means that it looks like two balls connected. So from rectangle, we do a double circle, and that's our small trick to create double and triple. So that's how we have the balls. This is the arc to create the glow on each ball. path ID, and the parameters are here also mentioned in the link I have in the repository, so you can play with it. And the last interesting element here is to add animation. So this is I1. This is how to create the eye. Again, we create a rectangle 30 by 30. So this is a single eye here that is going to appear. And this is already animated. It animates every 10 seconds. So this is one and the other. So this is a simple rectangle, but we add a parameter, a function to animate it. And the way we do it is that we say that it's going to fill with specific color. The animation will be for 10 seconds, and then we are going to loop it indefinitely, repeat count indefinitely. And now we provide the values that we will fill it with, so the colors. It's going to run for 10 seconds, so I provide 10 values, but the trick is here that 9 of those values, this 0, 0 at the end, means that this color is completely transparent. So for 9 seconds, we provide a transparent color, so it's invisible. And for second number 5, we provide a white color. So for 4 seconds at the beginning, it's nothing. Then for a second, it's white. For another 5 seconds, it's white. And then it loops, creating that every 10 seconds, we have an animated eye. So this is our SVG code, and this is what we want to recreate dynamically, that what we created in this tool here. So coming back to the code, we are ready to create the ball SVG code. And what we need. So this is actually quite simple. We don't need to pass many parameters because we created already a structure for the ball where we store all the parameters. So the only thing that we need to provide is the instance of that ball with structure, and that's it. And it's going to be an internal pure function that returns a string memory. And the way we do that is that we take this code for the ball. Like this is a code for a single ball, and we just replace all the elements that are dynamic. So X and Y, where the ball starts, this is dynamic. Height doesn't change, so it's 300. Color is dynamic, it changes randomly. And the parameters for the arc for this glow here is also that dynamic. So we replace all of that with the elements from our ball structure that we have created. And the code for this is here. So we ABI encode packed, so we create a bytecode, and this is the code, the SVG code that we have created a few minutes ago, and everything that is X and Y and dynamic is replaced with the parameters from the ball instance that we provided here. So as you can see, many ball instances, and we also, these are all numbers, uints. So we need to convert this into string, and this is what the last function does here. It's a pretty standard function to convert uint to strings used in many smart contracts. So I've just always copy-pasted from a contract to contract. And this way we create a SVG for the ball. Now, we have used quite some time already. So now I want to focus on probably the most interesting function in the whole smart contract. So we will spend some time on this, and then we will try and go faster after that. But this requires a lot of thinking. And I want to explain step by step how that thinking goes. So first, the parameters of this line. So for the line, what we need to provide? We need to provide if it's going to be line 1, line 2, or line 3, because it depends where we start drawing the line. So we provide uint line number, and as always, we provide the seed for the random number generator, random base. And what it is, it's an internal view function that returns an SVG code, which is the string memory. So this will return a SVG code for the whole line. Now, let's see. First, we need something to store the SVG code at. So we start with line SVG, which is empty. And as we will be creating the code for each ball, we will be concatenating that code and adding to this line SVG code. So we will be returning line SVG code that we will be generating here. So that's number one. We need to have where to store that code. Second, for each line, we need to know where it starts. So x is always a constant for each line because it starts at x 150. Each line starts at 150, but we need to calculate the y. And we need to calculate the y, and it's easy from the line number. Knowing the line number, we can calculate it. So by default, let's say that we start at row number 1, which is y at 150. If the line number is 2, then we change the y to 475. If the line is number 3, then we start at 800. So we have our y parameter, and now we are ready to create all the balls, the code for all the balls. And this is the way to think it. So it's not easy as it may seem. So for example, yeah, let's create the ball, the code for the ball. So we start with drawing the ball size for ball number 1. So let's say this is ball number 1, and we need to calculate the size of that ball. At this point, it could be either 3, 2, or 1. It could be triple, double, or single, and we draw it randomly. Once we have this one, and let's say it's single, then we need to proceed to ball number 2. And then again, we need to draw a random number for the size of the second ball. And it can be either double or a single. If it's a single again, then we don't need to do anything here because it's a single, and then we draw 3 singles. Or it could be double, then we draw a single and a double. So there's a lot of logic here. So calculate the ball size at slot number 1. If it's single, then we calculate the slot at slot number 2. And if it's single, then we paint a single for 1, for 2, and 3. If it's double, we paint double. And we only covered if the first ball is single. Now we need to cover what happens when the first ball is double. Then we draw the first ball as double, and then the last ball as single, because that's the only option left. And the easiest one at the end, if the ball is triple, then we only have a triple ball for the whole line, and we just return the code for that single ball, and we don't need to do anything else. So we need to cover all these use cases and create code for all this. But let's run through this. Line SVG. So this is how it's going to look like. We calculate the size of the first ball. The maximum is 3 at this point. It could be single, double, or triple. We return it in console log. If the ball is single, then we create a structure of the ball with the parameters that we need. So 300 by 300 is the size of a single ball. And then we concatenate that with, so we pass that to ball SVG function that we already have, which generates the SVG for a single ball. And then we concatenate that code with the line SVG, which we have at the top. Okay, so we have the first ball. Now we need to calculate the second ball. Again, we use the draw ball size function. And we, depending on the size of the second ball, if it's a single, then we create two single balls for number 2 and 3. If it's double, then we create a single double ball. And then we concatenate again ball 2 and 3 to the line SVG at the top. So that's if the first ball is single. If the first ball is double, then it's easy. We create a double ball and a single ball, and then concatenate the double and the single with the line SVG at the top. And if the ball is triple, then it's easy. Then we only return the code for one ball, and that's the whole line. This is the most complicated function in this smart contract, so I wanted to go in a little bit more details for this. Now let's run through the rest. It's pretty straightforward, and I'll try to go quicker now. So this is the function to draw the eyes. Now that we have the lines, now we can draw the eyes only in one location on one ball, and this is the parameter that we are going to pass. We are passing in which row we are going to locate those eyes, and then returning the SVG code for the eyes. So if the row is 1, this is the X and Y. So for this function to be simpler, we will be adding the eyes only to the last ball, because otherwise we would need to add even more code. So it could be either here, here, or here. We do not try to put it somewhere, because then we would need to check, for example, if the ball here is triple, because if it's triple, then we cannot put the eyes here because the eyes are at the end. So it would add more code. But every ball at the end, it definitely has a glow where we can put the eyes and make it a smiley. So that's what we... Oh, this is hard coded. This is... This is the final code for drawing the eyes. So again, we take the code that we created previously in the SVG tool. We are just replacing the Y parameter here for the dynamic one, so that we randomize the location of the eyes. So now we have everything. We have an ability to create a single ball. We have an ability to create a single line 3 times, or however many we want. We have an ability to draw the eyes. So now we are ready to generate the final SVG code for our NFT. And the final SVG code. This is where the randomization happens. So this is what creates the random base that I was mentioning throughout the code. So this is actually pseudo-random code, because everything is deterministic on the blockchain. So I'm taking the parameters for randomization like block base fee and block timestamp, but this is something that everybody can check on the blockchain. Everybody can see the timestamp, everybody can check the base fee or MSG sender, so the address of the wallet that is minting the NFT. So if it were a very sophisticated and very expensive NFT, then that wouldn't be good enough, because through a lot of effort and trial and error, someone could reverse engineer and try many times and come up with something that can be guessed and then influence the outcome of the NFT. So maybe have 2 or 3 triples, for example, in that one. But because we are not that concerned about it, we are just selling it for 001 and on testnet. So this is good enough. This is like pseudo randomization, and this is how we create the random seed, which we will then use elsewhere. So catch 256, this is the hashing function that we will create that seed. And for that hashing function, we pass a couple parameters. And we need we need 3 random seeds because we will be creating 3 line SVGs. And for each line, we need a different seed so that it's truly random. So that's what the generative final SVG code does, creates 3 random seeds, and then creates what we have seen at the beginning when it created SVG. So it creates this rectangle with the background color. Then it calculates where we put the eyes, in which row 1, 2, or 3, eyes location. And then it's ready to create the final SVG because we have everything. So we start with a view box that's square 1250 by 1250. On top of that view box, we add the background code, which creates a single color square, same size as view code. And then we pass 3 we create 3 lines, and we pass the line number to generate like SVG 3 times. So we get the code for line number 1, line number 2, line number 3. We can concatenate all of that here with SVG API encode packed. And on top of that, we have the code, we have all the lines. On top of that, we are adding the eyes with the animation, and we close the SVG. Done. We have created the SVG that we want to put on the blockchain, and this is what we return from this function. Now we are ready to create the token URI that will live on blockchain, and that will be immutable once we put it there, because everything will be inside that token URI, and then the image that will be created and that will be seen on OpenSea will be generated and taken from that URI that will be passed. So we are now ready to create that URI. And for that, we need to override the token URI function from this contract, from ERC-721 standard. We need to override it so that we can store our whole SVG code in the URI. So a few things happen here. This is the function token URI function. This one needs to be public because anybody needs to be able to. Actually, token URI maybe it doesn't. Yeah, I'll have to check later on. The minting function needs to be public definitely. So this one overrides the token URI function from ERC-721, and this is how it overrides it. First, it checks if the token ID already exists, and then we are encoding everything in base 64 because we need to create the bytecode. So we are encoding this, and then we have the string. The SVG that we are generating here is a string one, so we need to encode back and forth between strings and bytecodes. So there's a lot going on. So you can see string, bytes, encode, bytes, string. You can check this later on, but there's a lot of that going on here. And we need to provide a few parameters. So we have that SVG code. So that's going to be what we see on OpenSea, for example, when we open that. But we need to create more than that. So we created the image. Well, other than the image, we need to create. We need to create a few more parameters. We need to create the name, and we will not be truly creative. We will just say balls of art number 1, 2, 3, or 5. But if we wanted, we could name differently every NFT. and then we're providing the token ID with that number so that it's part of the name. And we create description. Description is going to be the same for every NFT. Again, we can make it dynamic, but we are creating this for, I think the testnet OpenSea is lagging. Okay, so hopefully it comes back when we want to deploy it. And once we have all that, then we here run our main function, generate final SVG, and pass it as part of the token URI. So it will all live in a very long URI string. Then we encode, decode, and put into the structure that it needs in order to generate the NFT. And now we are ready to mint. We have our token URI that we are ready to pass to the minting function. We are almost done with this part. So the last function is the minting. We are ready to mint. This is actually quite straightforward. And first of all, what I did, which is also unusual for NFTs, is that I have set the price. And this is this line, require MSG value. Value is how much ETH you are sending with the transaction. So MSG value is mint price or more. So you can send 0.001 or more. Usually it's you need to set a specific send a specific amount, and that's it. But because this is a cheap one, and because we are working with different concepts of how to play with NFTs, so if you put this on the mainnet and this is actual money, actual ETH, you can have it that someone who values your work can buy your NFT from you for the price that you set or more. They can send more, and you will get that price, and they will get the NFT. So that's something that is unusual with NFTs, but I just wanted to play with different concepts. So that's what this line does. The next one, this is where the magic happens. This is from the ERC721. This is the mint function. We are just providing two things: MSG sender, which is the address of the wallet that is minting. So if I'm minting, this is my wallet address where to send the NFT. And the token ID is the number of the ID of the token, and everything else will be generated based on that. And as I said previously, we need, at the very beginning, we need to increase the total supply by 1, which will send the variable of how many tokens NFTs are minted. The counter will be increased. And once we have this NFT minted, we emit the event balls created with a given token ID. And as it says, it's undeclared identifier because we haven't declared that event at the top. We just said where we want to include it. Now we are ready to do that. So with the events, we define the event, balls created, no error here. Boom. Let's see if that compiles. I hope it does. We didn't check it for a long time. Looking good, looking good. Boom. What happened? Let's do it again. Done. So it did create, it didn't have any errors. Now what we want to do is that we want to deploy it. We want to have it on the testnet. I know we are a little over time already, but now we are at the finish line where we are launching it. So please stay for the...
No worries regarding that.
Yeah, please stay for the good part. And what do we need to do? Now we need to configure this stuff here. ENV example. So for deployment, so for local development, we didn't need that. We didn't need the RPC because this is where we run our blockchain. We have a local blockchain on our machine. But for deployment, we are deploying to the testnet. So we need to be able to connect to it. So first, we need to create the env. Let's say duplicate. Okay, so we need to create the env file. And all of this needs to be secret because we will have the private key for our wallet, so we do not want to deploy it. For that specific reason, I have created a DD developer DAO burner wallet, which I will use here. But so that because I will be showing the private key here. Maybe it's not the best idea to show how many characters in my main password, but this is the private key for this specific account. And this is what we need to enter here. So private key, we are entering private key. Next, we need to be able to connect to blockchain, and this is what the RPC node does, and we can have a free RPC node on QuickNode. I'm already logged in, but if you're not logged in, you can create a free account. Just enter a name, email, and password, and that's it. And you will land, once you create your new account, you will land here. You will be able to create an endpoint. This is like a fresh account. And we create an endpoint. What we want to deploy to Ethereum. We have selected Ethereum, and now we are choosing where to deploy it, mainnet or testnet. These are all testnets. So we want to deploy it to Girly testnet. If you want them to deploy to main network, that's what you choose. But for now, we need the Girly endpoint to create the NFT. We do not, for now, need any add-ons, so we don't choose any add-ons, and we create the endpoint. Boom. Now we have multi-winter emerald. Sounds good. Now we need to copy this endpoint, and that's where we add this multi-winter emerald. Now we have created, now we are able to deploy that. But we also want to have an Etherscan API because we want to be able to mint, to actually go and mint the NFT. Etherscan. Yeah, I'll use one of mine. You can. This is again, if you go to etherscan.com and create an account, you can create 3 API keys for free. The reason that we want to do that is that we want to verify our smart contract on the blockchain, so that everybody can see the code and actually interact with the code on Etherscan. That's where we will be minting our NFT because we don't have the front end for it. Usually what happens is that you just create a nice minting experience, the minting page with the minting button where you enter how many NFTs you want or how much you want to pay with our minimum price, for example, but it's not what we have for now. Now let's try and deploy this. So the way to do that is we run a deploy script, and I have created a simple script which just takes the balls of art contract, deploys it, and says that it's being deployed, and that's it. So we are deploying it to network, to a test network Girly. Network Girly doesn't exist. Yeah. yeah, one thing that you need to do, hardcode config. When we are ready to deploy, we need to uncomment the girly in hardcode config.js. So we are uncommenting that. We are using the parameters that we have set in the env file. Quick note, API key girly, private key. We are ready to do that. And oh yeah, also I need some ETH to be able to deploy. So right now I have 0. Let's copy this, and I'll send myself some ETH from my different account. And let's say I'll send 0.1. Because we will be deploying, so we will be paying with Ether for that contract deployment. It will cost gas. Now let's see if we have ETH already in this burner wallet. Yeah, Garly is a little slow today when I work with this today. Yeah, boom, we have 0.1. So now we are ready to deploy. Now Girly should exist. It does exist. It's deploying. It usually takes, I don't know, 10, 20 seconds. And it should then go and create a contract. Boom, both of are deployed. And we are already on testnet. So we have created this. And we are, then this feels exciting. So girly ether scan. Early ether scan. We can see this is our test address. Boom, created 30 seconds ago. We have deployed the contract. Great. Now we want to interact with it, but for now we cannot do it because this is all bytecode, and that's why we needed the Etherscan API key. We want to verify that contract so that we can actually interact with the contract on Etherscan and actually mint what we have just created. For that, we need to provide the address to Hardhat to verify. It will use the Etherscan API key. This usually takes a little longer than contract deployment, takes some time. But once we do that, we will be ready to successfully submit source code for verification. Now it's waiting to verify. We are waiting for a green checkmark here next to contract. Once it's green, it means that the code is there for us to see and to interact. But we are getting there. We are closer and closer to having our collection on testnet OpenSea if we actually are able to load it. Boom, we have it verified. We have the green check mark here. This is our contract. This is what we have worked on the last hour and some. So now we are able to interact with the contract. So we can write the contract now. We connect to the contract with our wallet. Let's connect with the burner one. Doesn't want to. Let's try it again. There. It would be a shame to just go almost to the finish line for it to. No, it doesn't want to connect. It says connected. Let's try. Let's see if it's, let's say 0.001, which is what we said our price, and it doesn't. Extensions.
You can check out by resetting the MetaMask.
Yeah, I'm removing the extension and re-adding now. Maybe
Yeah.
it will work now. No. If anybody can do it, maybe. Yeah, but I would need to. We're so close. We are so close. Now the last thing is to mint
Yep.
our NFT, and then it will be visible on OpenSea. That's the last step that we need to do, but MetaMask just doesn't want us to. Oh,
And it can.
maybe,
Congratulations.
maybe we can do it. Maybe it will work now.
Hope for the best.
Maybe let's try. Firefox, maybe. Do I have the wallet set up there? I think I don't.
You can send me the private link on the private chat. I will try to showcase it.
Yeah, okay. Okay, so
But I will be needing, like some Goruli testnet, so that would be good.
yeah, MetaMask popular but not working. Yeah. So if you if you can paste me your wallet address, I can send you
Yeah,
some early keys.
just a second.
Okay, and send. Let's say 0.005.
Oh, come on.
Network is busy. It should be go through. So let's speed up.
Oh my god. I would be needing to like leave the screen for sharing it.
Okay, I think you should have the Beyond Blockchain Explorer. Yeah, success. So you should already have it.
Yep, I got it. But I will be
Um,
needing to like close up my screen for a minute. It will take a lot of time, to be honest.
okay, so maybe let's go quickly what will happen, because that's really the last
Yeah.
step. So the way that it happens, that we then go to this function, because that's the function that does everything. We enter the price. It could be 001 at the minimum, but it could be more. And we choose the token ID, let's say 1 or 11 or whatever. And then we click write. Then the MetaMask opens with this amount given that we need to send. we submit the transaction, and then it will then show up here, or maybe let's see. It will show up on the transactions list. So first will be
Yeah.
contract creation, then the minting function will be, and it will tell. Let's see. Yeah, Girl is really slow today.
You can check us the minting function over the contract you have created before.
Yeah, what's the contract I created before? Maybe, yeah, this. Yeah, maybe this. So let's try and see. Yeah, so this one was created 7 days ago. So this is and this is probably the same contract, yeah, balls of art. And then it says min balls of art. This is exactly the function that we will be running. And then it interacts with our contract that we created, and it creates balls of art, BART token. And then it will be, once we run that and once we mint that NFT, it will automatically then will be visible here when we enter the address of
Okay.
the contract. It says the address of the contract.
Yeah.
It says that it has one item, which we see exactly here. Here. And that's basically that then displays, and yeah, Girly doesn't want to cooperate with us today. It's
Yeah.
slow, and MetaMask as well. But we took it to the very end. Everything works well. Everything works properly. Everything compiled. We were able to deploy it. It is on the testnet, so whoever goes to that address, the wallet the contract address on the Etherscan after the workshop can mint. You can get in touch with me. I can send you some ETH, or you can quick note faucet. You can use quick note faucet to get some test. You choose ETH and Girly. You paste the wallet address. You get some test ETH to play with, and then you can mint the NFT, and it will show up on the OpenSea, on the testnet OpenSea. The same exactly if we were to choose the mainnet, it would go on the mainnet. It would be, you would be able to buy it, and with real money, real ETH. The next step is to create a minting page so that then it's a proper collection with a proper minting experience. And we have created a simple version of the NFT. You can create then next a more complex art structure. Maybe you can have more lines, not just three, more rows, maybe different shapes. Maybe you can take a favorite color from the minter as a parameter and then include that. Or maybe take an emoji as a parameter and then include that in NFT instead of the smiley face. Whatever you choose, you can do that. You can add true randomization if it's a proper NFT collection on the mainnet with the Chainlink Oracle. You can add more animation, the front end, and create more art. That's the next steps for this. Everything else is in here. Just clone this repository, and then you will be able to go through everything that we just went together up until the last point where the Girly failed us. But we did it. It's live on the blockchain. It's just the front end that fails. The blockchain works, the back end works, everything's there. So that's it. And yeah, ready for questions if there are any. We used a different private key. Now private key is fine. Different browser tried it. Do you have the Ethercan API key? Yeah, this one we already also done. So, okay, if there are no more questions, yeah, I'm ready to stay here for as long as needed. I'm having fun,
Yeah.
but we are way over time here. So, yeah, it was great creating this with you together. And yeah, hope you liked it. Sorry for girly not being up to speed, or actually the front end. Girly was fine. We deployed to Girly, and it's up there. We just
Yeah.
can't we just can't mint. But yeah, that's about it now. So thanks a lot for building it together, and I hope you can take it, and I hope you can run with it. I hope you can create more fun stuff with it. If you do, hit me up on Twitter, velvet_shark. Let me know what you have created. Let me know if you have any questions, if anything is unclear, if you need any test ETH, or just about anything about NFTs or smart contracts, let me know. I'm happy to connect and happy to build together. Thanks a lot.
That's awesome, Redek. And thank you everyone for watching this and for being present over here. And thank you, Redek, for presenting this awesome session. Like sometimes the luck doesn't favor, so no worries about that. And yeah, so everyone do subscribe to the Developer DAO YouTube channel, and you can check out the rest of the playlist. We have some great workshops already over there pushed, and this will be also be recorded. So yeah, see you guys very soon on the next workshop. Bye bye, everyone.
Thanks a lot. See ya.